In this video, we're going to look at position vectors. Now, a position vector is the vector from the origin to that point. Specifically, if O is the origin, then the position vector is O to A. So for a position vector, we're not given a starting point necessarily, we just have to assume that it is the origin of our situation. So let's look at a couple of examples of how we could use it. So we're told A has position vector 2A minus B, and B has position vector 3A plus 2B. And we're asked to find the magnitude of the vector A to B. Now what we're given is the position vector of A, so OA is 2A minus B, and we're also given the position vector of B, so OB is equal to 3A plus 2B. Now if we think about what this might look like geometrically, we have some point O, so we have some origin, put that here, and from that we've got two vectors. We've got to A, maybe that goes something like this, A down here, and that vector is 2 little a minus b, and we've got another vector from O to some other point B, and that vector there is 3A plus 2B. So we're looking for the vector AB, so that is the resultant AB here. And we can split this AB into how we would get from A to B. Well, we can see quite clearly from here that AB is equal to AO plus OB. But AO is just the opposite of OA. So that's going to be minus OA plus OB. And this actually gives us a general rule. When we're trying to find a vector AB, and we know the position vector of A and the position vector of B, we have this rule that AB is equal to OB minus OA. And we can see that here. If we start at A, we walk along from A, we walk along negative OA and then positive OB to do the blue walk, the blue vector. So now it's just a case of putting in what we know. Minus OA is minus 2A's plus B, and plus OB is plus 3A's plus 2B's, and that gives us that AB is equal to A plus 3B. But that's not the answer, because the question was asking us for the magnitude of AB. So we need to do the magnitude. That's AB, the magnitude of AB is equal to the square root of 1 squared plus 3 squared, which is equal to the square root of 10, which is equal to 3.16. Now let's look at a second example. And in the second example, we're given the position vectors of P, Q, and R, but R is given as mu A minus 6B. We don't know what the multiple of A is. Mu is some scalar number. We're told that P, Q, and R are collinear, so they're all in a straight line. And first of all, we're asked to find the value of mu. Now, since they are collinear, we've seen this result before, since they are collinear, we know that PQ is equal to some multiple, let's call it K, of QR. Because they are collinear, we know that any vector between any 2 points are parallel, so they are scalar multiples of each other. Now, since we know that, we can use that fact to help us find mu. But let's first of all think, well, what is PQ? Well, PQ is equal to, well, from the previous example we saw that's equal to OQ minus OP, which is equal to, well, OQ is the position vector of Q, so that is 2A minus 3B, and P is A, don't forget, minus 2B will give us plus 2B, which gives us 2A minus A is A, and minus 3B plus 2B is minus B. So PQ is A minus B. Now QR, this is the other bit we need for this part here, QR is equal to, similar process, OR minus OQ. We'll do it in one step this time. So let's look at the A's. We have mu A minus 2A. So that is mu minus 2A's. And then look at the B's. We have minus 6B minus 3B. So minus 3B, so plus 3B gives us minus 3B. Don't forget there's minus the minus 3B. But we know that these two that we've just worked out, PQ and QR, satisfy this because they're collinear. So one is a multiple of the other. And we can see here that we have to multiply B by 3 to get 3B. So if we have to multiply B by 3 to get 3B, we're going to have to multiply A by 3. So that means that this whole bit here must be equal to 3, and so mu 5. Now we've found the value of mu. We can carry on, do part B. The ratio PQ to QR, we can see this easily because QR was 3 times by PQ. We use that to find mu. So the ratio is 1 to 3. So position vectors are just a vector